So we've all seen AI that can whip up a line of code or even a whole function. But what happens when the task gets huge? I'm talking about changes that touch dozens, maybe hundreds of files across an entire code base. Well, today we're going to break down a new framework called CodePlan that's built to do exactly that. This isn't just about code completion. This is about an AI acting as a full-blown coding architect.
Here's how we're going to do it. First, we'll talk about the wall that current AI coders slam into. Then, we'll see how CodePlan completely changes the approach, making the AI think like an architect. After that, we'll pop the hood and see exactly how this machine works, check out the pretty staggering results, and finally, take a look at what this all means for the future of automated coding.
All right, let's jump right into our first section, the AI coding wall. This is all about understanding why the tools we have right now, as amazing as they are, just aren't enough when the job gets really, really big. And that really brings us to the core question, doesn't it? If you've used something like GitHub Copilot, you know it feels like magic for writing a single function. But what if you ask it to do something like, say, migrate your entire project to a new version of a library? Suddenly, it's a completely different ballgame.
You see, developers basically live in two loops. You've got the inner loop, which is our day-to-day, writing a new function, fixing a small bug. The analogy here is perfect. It's like decorating a single room. It's contained, and our current AIs are fantastic at it. But then you have the outer loop. This is the heavy stuff, migrating an entire library or squashing a bug that's everywhere. This isn't decorating a room anymore. This is rewiring a skyscraper. Everything is connected. And that right there is where most AI tools just hit a wall.
And this slide, this shows you that skyscraper problem in vivid detail. On the left, a developer makes what looks like a super simple change, just updating how a function is called. But look at the chaos on the right. That one little change creates this ripple effect, this cascade of build errors, all those angry red lines. Because you see, that function is called by other code, and now that code is broken. And maybe those are called by 50 other things. It's this domino effect of failure that just spreads across the entire project.
That exact chain reaction is the problem CodePlan was built to solve. So let's get to the solution. This is about a whole new way of thinking. It's about shifting from being a decorator to being an architect.
Okay, this is the big aha moment. The core idea is this. Instead of just reacting to errors one at a time, CodePlan treats a giant coding task as a planning problem. Think about it. A real architect doesn't just start laying bricks and hope the windows fit. No, they draw up a detailed blueprint first. CodePlan does the exact same thing, but for code.
And here it is. This is the blueprint. This is the big picture of the CodePlan framework. You can see it's a cycle, right? It analyzes everything, it creates a plan, it uses an LLM, a large language model, to execute a step, it analyzes the impact of that step, and then it adapts the plan. This is the machine we're about to go inside.
All right, let's get our hands dirty and look at the mechanics. If you're here to understand the actual methods and procedures, this is your section. We're going inside the CodePlan machine.
So the whole process really breaks down into 5 key steps. First, it analyzes dependencies, basically mapping out the entire skyscraper. Second, it creates an initial plan to get things started. Third, an LLM executes one single step of that plan. And then, and this is absolutely crucial, it analyzes the impact of that change. Fourth, based on that impact analysis, it adapts the plan, adding new tasks to fix what it just broke. And finally, fifth, it just repeats this loop over and over until the job is done, and an oracle, which is basically a build check, gives it the final thumbs up.
Now, the absolute foundation of this entire system is something called the dependency graph. You have to understand this part. Just think of it as a super detailed X-ray map of your entire codebase. It doesn't just see files. No, it knows that this specific method calls that specific method, or that this class inherits from that other class. All the connections.
And this visualization makes it really clear. Every box is a piece of your code, and those red arrows are the relationships between them. You can see the labels, calls, overrides, parent of. This graph is literally how CodePlan sees the project. It's how it understands that if you touch something over here, something way over there is going to feel it. This is the architect's blueprint.
Okay, so because it has this incredible map, CodePlan can give the LLM 2 extremely powerful types of context. First is spatial context. This comes from that dependency graph, and it answers the question, what is this piece of code connected to? But then there's temporal context. This comes from the plan itself, and it answers, why does this code need to change right now? It's the difference between seeing a picture of a bathroom and knowing that the plumber's just ripped out all the pipes 5 minutes ago.
And here is the stone-cold proof of why that temporal context is a total game changer. Look at the top example. With that context, the LLM knows a related function just got an update, so it correctly changes the code from legacy logger to modern logger. Perfect. Now, look at the bottom. Without that history, without the why, the LLM is flying blind. It has no idea it needs to change anything, so it just leaves the old broken code right there, and the whole task just fails.
So, the theory is solid, the method is brilliant, but does it actually work in the real world? Let's move on to Section 4 and look at the results.
CodePlan was tested on 6 incredibly complex, real-world tasks, the kind of stuff that gives developers nightmares. And check this out. It successfully completed the task and passed all the final checks on 5 out of those 6. That is a massive, massive win.
Okay, so what about the other methods? The ones that don't have a master plan and just react to errors as they pop up. How many did they complete successfully? 0. A big, fat 0. Not a single one of the 6 tasks made it through. It was a complete and total failure. So why was there such a huge difference? Well, it all comes down to proactive planning versus reactive repair. CodePlan uses its map, that dependency graph, to perform what's called a change may impact analysis. Before it even writes a line of code, it looks ahead to predict everything that might break. The other methods, they're just reactive. They make a change, wait for the build to fail, and then try to patch up whatever error it spits out. But often, they're just treating a symptom, not the actual disease, and the whole thing just crumbles. And that brings us to our final section, the future. Because this isn't just some interesting academic paper. What we're seeing here points to a fundamental shift in how we might build software in the years to come.
And believe me, the work is far from done. The researchers have laid out a really ambitious roadmap. First up, they want to support dynamically typed languages like Python and JavaScript. That's a huge challenge because their connections aren't always obvious until the code is actually running. Next, they're going after even trickier problems like data flow and multi-threading, the kind of bugs that make senior developers want to cry. They're also looking to expand beyond just code to edit things like config files and other metadata. It's evolving from a code editor into a true repository manager. This thing has a ton of room to grow.
You know, putting together an explainer like this also requires a bit of a master plan. And the most important first step in that plan, it's getting awesome viewers like you to subscribe to VibeDoc. It seriously helps us out, and trust me, you do not want us to send a poorly prompted LLM to try and convince you.
So we want to leave you with this final thought. For a while now, we've seen AI as a pair programmer, suggesting the next line of code. But with CodePlan, we're seeing the AI step up to become the software architect, the one who plans and executes massive changes across an entire system. So, if the AI can now draw the blueprint for the skyscraper, what does that mean for the future of building software? And what human role will it start learning how to do next?